In this video, I wanted to point out three different forms of the variations of sine and cosine functions. In all these three forms, the graph is stretched or shrunk vertically and horizontally, and it is shifted to the left or to the right. Depending on the textbook, the variations of sine and cosine functions are given by the forms we see either in column 1, column 2, or column 3. In column 1, the forms are y equals a sine of bx minus c and y equals a cosine of bx minus c. In column 2, we have y equals a sine of bx plus c and y equals a cosine of bx plus c. So the difference between these two is that here we have a minus c and here we have plus c. Now in column 3 we have the forms y equals a sine of b parenthesis x minus c and y equals a cosine of b parenthesis x minus c. So as you see here, b is factored out, and if we would remove the parentheses, we would have bx minus b times c. So again, depending on the textbook, you may see this form or this one or this one. Now notice that for all three forms, the formulas for amplitude and period are the same. The amplitude is found by taking the absolute value of a, and it shows the maximum value of the function. The period is found using the formula 2 pi divided by b, and it represents the interval on which the function completes one full cycle. So because of this b, the graph will stretch or will shrink horizontally. Now let's talk about the phase shift. This is a point where the cycle will start. Notice that depending on the form, the formula for the phase shift is different. For these forms, the phase shift is equal to c over b. For these forms, the phase shift is negative c over b, and for these forms, the phase shift is just c. Now I will show you an example and I will write it in all three forms, then we will find the phase shift. So let's say we have the function y equals 5 cosine of 3x minus 6. We clearly see that this function has this form, and we can determine that a is 5, b is 3, and c is 6. So again, a is 5, b is 3, and c is 6. And now let's find the phase shift. To find the phase shift, we have to divide c by b, and in this case c is 6 and b is 3. Then the phase shift equals 2. Now I will take this function and write it in this form. And because here we have plus c, then inside the parentheses, instead of 3x minus 6, I will write 3x plus negative 6. So then we will have y equals 5 cosine of 3x plus negative 6. So again, this is exactly the same function. And now we can say that a is 5, b is 3, and c is negative 6. And let's write this below. A is 5, b is 3, and c is negative 6. And now let's find the phase shift. The formula has a negative in front and then a fraction, and we need c in the numerator, and c is negative 6, and b is in the denominator, and it is 3. Then these two negatives will make a positive, and 6 divided by 3 is 2. So as you see, we got the same result as with the first form. Now I need to rewrite this function so that it matches the third form. For this, I will factor out 3, and then I will start parentheses, and inside the parentheses I will have x minus 2. So the function will be y equals 5 cosine of 3 parentheses x minus 2. In this form, a equals 5, b equals 3, and c equals 2. I will write this below. A equals 5, b equals 3, and c equals 2. And now the phase shift is equal to c, which is 2. So in all three cases, the phase shift is 2. So remember that if you have this form, you have to use this formula for the phase shift, and you cannot use these two instead. And if you have this form, you have to use this formula, and with this form, you have to use this formula. Now, I want to explain to you where these formulas for the phase shift are coming from. In each of these forms, to find the values of x for which the function completes one full cycle, we need to take the expression under the sine or cosine and set it between 0 and 2 pi. In the first column, the expression under the sine or cosine is bx minus c. So we will take this expression, bx minus c, and we will write an inequality setting bx minus c between 0 and 2 pi. And 2 pi is the period of the basic sine and cosine functions. Now we need to solve this inequality for x, and for this we will start by adding c to all three parts. To the left, 0 plus c is c. In the middle, negative c and positive c will cancel, and we will have bx, and to the right, we will have 2 pi plus c. And now to get x alone, we will divide all three parts by b. Then to the left, we will have c over b. In the middle, b and b will cancel, and we will have x. And to the right, we have 2 pi over b plus c over b. Then here, c over b represents the x-coordinate where the cycle begins, and that's why the phase shift is c over b. And this is the x-coordinate where the cycle ends. It is the sum of the period and the phase shift. Now, with the second form, to find the values of x for which the function completes one full cycle, we will take bx plus c and we will write it between 0 and 2 pi. So then, bx plus c is greater or equal to 0 and is less than or equal to 2 pi. To solve for x, first we will subtract c from all three parts. Then to the left we will have negative c. In the middle, c and negative c will cancel, and we will have bx, and to the right we will have 2 pi minus c. And now we will divide everything by b. Then on the left we will have negative c over b. In the middle, b and b will cancel, and we will have x. And to the right we will have 2 pi over b minus c over b. So here, negative c over b represents the x-coordinate where the cycle begins, and that's why the phase shift is negative c over b. Then the expression to the right represents the x-coordinate where the cycle ends. And now let's talk about the third case. The expression that we see inside sine or cosine is b parenthesis x minus c. Just like in the previous cases, we will write this expression between 0 and 2 pi. And now, because this expression represents a product, we will start by dividing all three parts by b. So we will have 0 divided by b, then b times x minus c divided by b, then 2 pi divided by b. Then to the left we will have 0. In the middle, b and b will cancel, and we will have x minus c. And to the right, we will have 2 pi over b. Now to get x alone, we will add c to all three parts. Then to the left we will have c. In the middle, negative c and positive c will cancel, and we will have x. And to the right, we will have 2 pi over b plus c. So this c is the x-coordinate where the cycle begins, and that's why the phase shift is c. Then 2 pi over b plus c is the x-coordinate where the cycle ends. So again, with form 1, the phase shift is c over b. With form 2, the phase shift is negative c over b. And with case 3, the phase shift is c. I hope you enjoyed this video. Please subscribe, leave a comment, and thank you for watching.